Hello, welcome. In this presentation, I'm discussing how platform security architecture and its security evaluation scheme for IoT, PSA certified, are helping the electronics industry to improve IoT security. PSA certified has been developed by 6 founding members, logos shown here. It's freely published on www.psacertified.org, and it has an independent certification body, TrustCB, to manage the quality of the scheme. This presentation provides the latest information on PSA Certified, how you get involved, and why that matters to everyone developing IoT products. PSA Certified is 1 year old. It's already attracting a lot of industry momentum. At Embedded World last year, most of the world's top 10 chip vendors launched their PSA Certified Level 1 products, some pictures shown here. And this is creating a really good solid foundation built on this PSA rooted trust with its built-in security functions for the industry. Today, we've got over 30 PSA certified level 1 solutions from partners such as Renesas, ST, NXP, Microchip, Cypress, and a growing number of software platforms and OEMs. We're on a multi-year journey to heal IoT security fragmentation to make life easier for IoT developers and OEMs. And this year, we continue to build that momentum by publishing the 2020 version of PSA Certified Level 1, which is aligned to the latest ETSI, NIST, and emerging IoT law. We also had our very first PSA Certified Level 2 certifications. So let's look at the agenda. I'm going to start by looking at the IoT security landscape and look ahead to a new problem of IoT security standards fragmentation. We'll look at the latest on PSA and PSA certified, how that's being developed to align various standards and IoT requirements to heal that fragmentation. And we'll look at a new method of establishing trust across the value chain called Entity Attestation Token. And finally, we'll look at how you can get started with PSA Certified, where the resources are and what to download. We live in an era of digital transformation enabled by the Internet of Things. That revolution requires trusted data. Before you use an IoT device to change some physical parameter or even for insights on data, you need to trust the data. When you need to trust the data, it turns out you need to trust the device. To trust the device, you need to, if you look deeply within it, you need to actually trust the root of trust, which is a small, carefully designed part of the system, requiring some trusted hardware and trusted software. So we'll dig into the root of trust a bit later on. PSA Certified specifies a particular PSA root of trust. It provides the security requirements for that in something called a protection profile, and it makes that easy to use via simple high-level API to hide the complexity of the hardware and software of that root of trust. In the 2010s, we had the Wild West years of IoT. There was a continuous stream of broken IoT news stories. 2015 was the year of the famous Miller and Valasek Jeep Cherokee hack. They found they could take over the car's control system, drive it off the road, affect the braking and steering in a carefully designed white hat attack. In 2016, we had the Mirai botnet causing major internet outages. 2017, there was a case in the news of a casino being attacked via the thermostat on a fish tank. 2018, a Bluetooth lock, which actually provided very little security. And these were just, the regular news stories, week after week, month after month. Last year, those news stories continued. Most of those hacks use simple vulnerabilities that should be addressed through good security principles. ARM has provided security model goals that are embedded into the latest PSA Certified Level 1 questionnaire to help developers avoid the common mistakes that often led to these news headlines. So if 2010s were the Wild West years, then 2020s we see as a decade of security regulations, and particularly a growing set of regulations and frameworks and questionnaires, all pointing in slightly different directions with different wording and features. And that makes a very confusing landscape. If you're an IoT developer or an OEM, where do you start? Which ones do you work with first? And that's one of the problems we are solving with PSA Certified. So we believe to navigate this world of multiple security regulation, we think there are some basic needs. Firstly, to demonstrate that you are abiding by good security principles and industry best practice, those security principles having first been methodically developed. We believe that the devices need to make use of a good quality root of trust, for example, our PSA root of trust with its built-in security functions, and to use a foundational security assessment covering those multiple major regional IoT regulations and have that independently assessed. So PSA Certified is aligning the wording on its Level 1 questionnaire to provide mappings for NIST 8259, ETSI 303645, and the emerging state law. So let's have a look at platform security architecture and PSA Certified and how that helps heal that fragmentation. So we announced platform security architecture back in 2017. PSA Certified is the fourth step in this process. So the first step is to analyze your security requirements, create a threat model, do a security analysis, work out what your assets are, what the threats are, what your security requirements are. Without that, it's very difficult to know if you've actually met your security requirements. We propose that people should use a well thought through security architecture that comes with a security model, has a firmware architecture document, and hardware requirements. So we have that with our PSA set of documents. We want people to do a good implementation, and a lot of that revolves around having some good low-level firmware. So we've created an open source, open governance project called Trusted Firmware. And Certify is the fourth step in that, which is the independent security assessment of the chip, the software platform, and the device. So it comes with 3 levels of increasing assurance and robustness. Say people don't mark their own homework. It has independent test lab based assessment, and it enables developers and particularly OEMs to choose silicon with the right level of security robustness for their particular market and application. So let's have a look at the PSA root of trust. It's a source of integrity and confidentiality for the system. It separates the critical security functions from the rest of the system. So we call that part, the secure processing environment, the SPE, shown here within that sort of green padlock shape. That's representing some hardware isolation from the rest of the system. And inside that PSA root of trust, there are some well-designed and evaluated security functions, things such as secure boot, secure storage, a cryptography library, an attestation method, and perhaps audit logs. And typically then that PSA root of trust can be developed by experts at the chip vendor, for example, by porting the Trusted Firmware M open source software to their secure hardware. So let's have a look at PSA Certified in a bit more detail. PSA Certified is dedicated to chips and devices that use this concept of a PSA rooted trust, this new security component that is now widely available from chip vendors. It's a simple three-level scheme, a good, a better, substantial amount of security assurance and robustness. It's been developed and backed by reputed experts, and it builds on years of work. So IoT threat models, so we can find the common security requirements, the platform security architecture documents, things like the security model and firmware framework, and also increasingly government best practice and protection profiles. It's scalable to the IoT ecosystem, so we've launched this with test labs with a global footprint, so that wherever you are in the world, you should be able to access a test lab in your region, and we've made it compatible with complementary vertical evaluations. Okay, so let's have a look at PSA Certified. It's been designed to be easy to understand. There's two parts to it. The logo with the padlock represents the security certification with 3 levels of increasing security assurance and robustness. So PSA Certified Level 1 focuses on security principles. PSA Certified Level 2 focuses on the quality of the root of trust, showing that protects against software attacks. And at Level 3, the root of trust protects against both software attacks and hardware attacks. There's a second part to PSA Certified, that's PSA Functional API Certified. That enables the ecosystem to use a consistent high-level interface to the root of trust. So it hides a lot of the complexity of that security component, makes it easy to use for software developers and device makers. So let's have a look at PSA Certified Functional APIs. It's a key really to simplifying security adoption. We want to enable products to be developed quickly, fast time to market, and that can be helped by abstracting the security complexities behind this high-level, easy-to-use API. We can also reduce fragmentation by encouraging the ecosystem to adopt and chip vendors to provide these APIs across their chips. And it can lower total costs of ownership and maximize return on investment through reuse of APIs. So you can reuse software, reduce complexity and development time. So this picture shows the PSA rooted trust there in that padlock with some built-in useful security functions such as crypto, attestation, and secure storage. That is typically interfacing to some security hardware shown there on the right. The chip vendor does that port of the hardware with the trusted software. And then you can think of the PSA functional APIs somewhat hiding the complexity of that subsystem, that security component behind this high-level API, so that the RTOS and applications can make use of those hardware-based security functions. So we talked about PSA Certified, the security part having 3 levels of assurance. PSA Certified Level 1 is the baseline. It's been built on some methodically created IoT threat models, 10 security goals, and increasingly the regulatory requirements. It's a security questionnaire with around 50 security questions that the developer can fill in. It's available in sections. You can see in this checklist that there's a section for the silicon vendor, section for the software platform, and a section for the device maker. And so this is sort of composite style. Level 2 and Level 3 focus in on that PSA rooted trust. So that's lab-based evaluation then of the combination of that trusted hardware and trusted software. Level 2 is this middle level of assurance, so time-limited white box testing, so-called ANSI CSPN style, and protection, showing protection against scalable software attacks. And Level 3 provides assurance against and robustness against both software attacks and hardware attacks. So, for example, in this case, side channel attacks, perturbation would be in scope. PSA Certified Level 1 is, say, a security questionnaire. One of the important quality aspects of that, it's been very methodically developed. So some of the sources for those questions have been our library of IoT threat models. So we have a set of different IoT devices where we've done the analysis, come out with a set of security requirements. So we find the common security requirements across these products. We have our security models, and so we have 10 security goals, and we have government regulation, so providing different regional input into our questionnaire. And together, then that provides a really well thought through security document, and I say it can be actually filled in sections, or if the OEM wants to, they can answer all 50 questions together. I mentioned that PSA comes with a security model. In that security model are the 10 security goals shown here. I won't go through them in detail, but please download the security model to read that in depth. But it includes things such as having a unique identifier for the device so you can update it, security life cycle, an attestation method so you can make some hardware-backed attested claims, a secure boot so you can build in the integrity into the system from power on, a secure update process, protection against rollback, isolation, hardware-based isolation so you can secure the trusted part of the system, enabling trusted interactions across boundaries, the ability to do secure storage, particularly of things like keys and certificates, and a really good quality cryptographic library. So together, we think these are the fundamental building blocks of a secure system. So this is really part of our security model, and it's built into the questionnaire. So PSA Certified Level 1, as I mentioned, there are sections for the device maker, the software platform, and the chip vendor. It's around 50 security questions based on those inputs of our security model, governmental requirements, and emerging law. It's, say, either composite or all in one go, and it should be very fast for a developer to fill in. So you can go online, download that form, fill out your relevant sections as a developer, and take that to a test lab to be assessed. And the major new thing of the 2020 version of this Level 1 questionnaire are the new industry alignment mappings to ETSI 303645, NIST 8259, and Californian state law. So looking at some of the sort of major alignment points, so in our 2020 version, that's version 2 of this Level 1 certification document, you can see sort of the various mappings across different requirements and regulations. So ETSI 303645 is a standard that's being developed, particularly important in Europe. And we are looking at sort of obviously alignment around things such as authentication and password and crypto and hardening, privacy, secure storage and update. NIST 8259 going to be important in the United States, and they add to that things such as secure configuration, hardening and logging. And California state law has particular requirements again around using not having any default passwords. So bit by bit, we can map those into the security questionnaire. So at the back of the Level 1 questionnaire, if you look at the appendices, you can see the various mappings from PSA certified questions to NIST questions and ETSI questions and California state law questions, and indeed draft UK DCMS regulations. So that's going to be a really useful aspect to doing PSA certified, as you can have some evidence that you're meeting various security requirements around the globe. PSA Certified Level 2 changes the scope from the device down to this PSA Root of Trust. So it's primarily for chip vendors, and for them to do a white box evaluation of that PSA Root of Trust. So take that device chip to a test lab for penetration testing. It's 25 days of vulnerability analysis and pen testing, and basically shows that the chip protects against scalable remote software attacks. And we think this is a really useful level for a lot of IoT devices, particularly if they're using unique keys per device. So in a bit more detail, the chip vendor provides obviously a real chip on a board, target of evaluation, but also some documents, that's the security target and evidence, showing how they met the security requirements for the PSA Root of Trust. They take that to an accredited security lab, such as Brightsight, Riscure, CAICT, and UL. Those labs use some scheme documents, so they include the protection profile with its 9 security functional requirements, an evaluation methodology in this CSPM style, and a set of attack methods focusing on scalable software attacks, attack potential 16. And then the labs submit the evaluation test reports to the certification body. So TrustDB reviews that, and if everything is good, they get to use a logo. PSA Certified Level 3 provides substantial protection from hardware and software attacks. So now, for example, glitching, side channel attacks, DPA, etc. become in scope. Similar attack potential evaluation methodology used on mobile TE. And the scheme is going to be ready for partners in the second half of this year. So PSA Certified then provides a lot of assurance for the whole value chain. So you can, the chip vendor can get their chip certified at level 1, 2, or 3. The software platform can have a level 1 certification showing the software is developed to good security principles, and similarly for the device manufacturer. And together then that provides a consistent industry-wide approach to security, delivering assurance across the value chain. And that's really important because it helps underpin business. It ensures we have devices with market acceptable assurance, and that can protect the reputations of OEMs and relying parties. It can enable a new operation or new businesses because you can trust the device and trust the data, and provide new financial opportunities. It can also underpin new businesses such as cyber warranty and underwriting, because if you can have independent assurance that the device is being developed against good security principles and it's got a robust root of trust, then risks can be managed. But there's another side to this, where actually we can also reduce costs and of addressing opportunities. So, for example, by enabling the industry to use some open source software to be able to have some common APIs across devices, then we can actually reduce the cost of developing a device securely. So I want to mention a new method of ensuring trust can be communicated across the value chain. So we'll talk a little bit about something called entity attestation token, making security transparent to the value chain. So thinking about your mobile phone, Today's smartphones are secure devices. Perhaps when they first came out in the early 2000s, that wasn't the case. So you could get a smartphone and within 2 weeks there'd be some jailbreaking code available on the internet. You could download your own software and overwrite it. That's typically not available today. Mobile phones have just got better and better in terms of security over the years. And partly that's because it's a fairly small industry, because you've got a small number of expert chip makers who build in those roots of trust. It's got a small number of expert software vendors who are committed to doing over-the-air updates. And the security architecture is based on a family of security components, so things such as the global platform trusted execution environment, providing a hardware isolated source of confidentiality and integrity, security enclaves such as Strongbox and secure elements work together to provide a really secure system. And that whole industry works without extensive security certification. The OEMs tend to know their chip vendors and software partners very well. Okay, but what about all the other IoT devices? There you don't know a lot about the device, probably you don't know much about the device manufacturer, what security model they're using, the software that's inside, possibly not even know the chip vendor, and whether they've got a quality root of trust. You might not even know how many years of software updates you're going to get, how robust it is, whether it's seen the inside of a test lab, has it got a security certification. Pretty much you don't know very much at all about the security of most IoT gadgets, and that's not a good situation. So what we're proposing is the use of entity attestation tokens that can be effectively provided from the root of trust. Think of this entity attestation token, this EAT, as a crypto signed report card with some useful claims. So it might say my hardware version is X and my software version is Y and my security certification is Z, for example. And it can be consumed by the value chain. So wrapped around the token will be a verification service that can consume these tokens. But all the small devices effectively should be able to provide an entity attestation token. So we've built this into our open source software reference implementation, for example. And we think that's a really powerful technology to communicate trust across the value chain that's rooted in that PSA root of trust. So there's a new white paper available if you go to the resources section of www.psacertified.org if you want to find more about EAT. And finally, how do we get started with PSA Certified? Well, the first thing is the good news that actually the ecosystem is adopting PSA Certified. There's a lot of chip vendors, software partners, growing number of OEMs embracing PSA Certified. So particularly important that there's chip vendors support this because they're building in that high quality PSA root of trust. So at level 1, I say there's over 30 level 1 certified products. At level 2, we've got 6 companies announcing that they're doing level 2. Either they've done it or they're in the lab. And also with the high-level APIs, making that security component easy to use, there's a growing number of chip vendors and software platforms that are adopting the PSA functional API certified. So good that there's market momentum. How do you as a developer or an OEM get started? For level 1, that's easy. Go to psacertified.org/resources, download the questionnaire, follow the step-by-step guide, fill out the section that's relevant for you. If you're a chip vendor, you can also do a PSA Certified Level 2 or Level 3 on your root of trust. If it's Level 2, you can go and download the PSA root of trust protection profile. You can also get an attack methods document, an evaluation methodology document from any of the PSA GSA members. Level 3, that's work in progress at the moment, so we'll have that ready by the second half of 2020. So please contact us if you're interested in that. And for the functional APIs, then you can download the step-by-step guide, access the test suites and run them yourself. And if you give us the test log, then you can have the PSA Certified Functional API logo. So in summary, we've moved from the 2010s, which were the Wild West years of IoT, to this new confusing world of IoT security requirements, standards and law overload. We're helping developers and OEMs navigate that by aligning the language and the questionnaire to meet the needs of important regional requirements like NIST and ETSI and various emerging law. So PSA certified healing fragmentation, you can start here effectively and provide evidence for multiple schemes. And the electronics industry is adopting PSA and PSA certified at scale, making it easier to demonstrate and communicate best practice. So to get started, please visit www.psacertified.org. So there's lots of useful resources. Have a look at the certified solutions on the showcase. There's a lot to read and get started on that website. Well, thank you very much for your attention today, and I hope you enjoy the PSA certified resources. Thank you.